Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about delegates, lambdas, and anonymous functions. Okay, so delegates, they are a really powerful C# feature. They basically let you store a function inside a variable or use it as some kind of parameter. Here is a working demo. So I can click and it spawns a chat bubble. Then I can press a button to change the action. And now if I click, yep, now it spawns a regular sprite. And now press another button. Now I click and yep, now it's spawning some particles. So the same action clicking is doing different behavior based on what action I select. Here is the code for the click actions. And the delegate is this one over here. It's something of type action. This is a delegate. And then I've got a bunch of functions defined here. So spawn chat bubble, a sprite, or a particle effect. And I can see over here on start that I'm assigning the click action to this function. So importantly, it is not calling the function. Nope, it is passing in the function itself and storing it over here inside of this field. And then on mouse click, I simply run whatever is stored inside that variable. So the variable stores a function, and then by calling this, I can run whatever function is stored within that variable. Then these buttons simply do that. They simply assign a different function onto that variable. And with that, I can click, do one behavior, press to select something else, do another behavior, another one just like that. So this is a practical example. Now let's see the syntax. To define a delegate, first let's write the access modifier. Let's go ahead with private, and then let's use the keyword delegate. And then you write essentially a function signature. So let's make something super simple. For the return type, let's use void. Then for the name for this delegate, let's call it attack delegate. Then we add any parameters we want, or basically none of them. Okay, so yep, so just like this, we have defined our delegate type. Now we can use this type just like we can use any other type. So for example here, let's make a field of this type. So let's make it of type attack delegate. And let's give it some name like attack action. Okay, so just like this. And then, like I said, the goal is you can store functions inside a delegate variable. So over here, let's make a regular function. Let's call it melee attack. And let's just do a console.writeLine. And let's print out melee attack. Yep, just like this. Now, importantly, we need to make sure that this function signature has to match our delegate signature. So it needs to match a return type, so both need to return void, and needs to match a number of parameters, so in this case 0. So with this, yep, now we can go inside our attack action, and we can assign it to our melee attack. And again, importantly, we assign it just like this, so we assign the function itself. We do not call the function. No, this is very different. We assign the function itself just like this. So you can do this, and then basically we can run whatever function is stored within this delegate. And we do that by calling it like we call any other function, so just like this. Okay, let's test. And if exactly it ran our melee attack function. So for example, you could have multiple enemy types, each with different attacks. In order to trigger those different attacks, you would simply assign a different function onto the delegate variable. Then, like I said, the delegate can have whatever return type and whatever parameters you want. So for example, let's make another delegate. Let's make one that returns int, call it my delegate, and let's receive a string parameter. So you have just like this is the delegate reference. And like I said, when assigning something of this type, so for example, down here, let's make a field of this type, my delegate. And now when assigning it, like I said, it needs to match the function signature. So if I try assigning melee attack, and nope, we have an error. It is telling us that there is no version of the melee attack function that matches the delegate my delegate. So there's no version of this function that returns an int and takes in a string. So in order for this to work, let's go make a private static void my test function, and actually not void, so actually in here let's return an int and let's receive a string parameter. So we have this one, and now up here we assign this to this field of type my delegate, and yep, now it does work. Let's just return 0 just to fix that error. And yep, like this does work. It works because the function signature now matches, so they both return an int type and they both have a string parameter. Also, by the way, over here you need to define some kind of name for the parameter. So like this, it's an error, so you need to define it with some kind of name. But down here, when you assign the proper function, this one does not have to have the exact same name. It needs to be the exact same type, but not the exact same name. Okay, great. So this is the basics of delegates. So up here we define a delegate and then we assign it. So that's great. And delegates are really super useful. I use them all the time. But always having to define them before you use them, that is a little bit of a pain. So for that, C# has some really awesome default delegates that are super useful. One of them is simply called action. So let's make a field and let's make it of type action, which by the way exists inside the system namespace. So action, let's call it my action. And we can inspect the action in order to see the function signature for this delegate. And yep, this is a delegate that returns void and takes in no parameters. So pretty much exactly the same that we defined up here. So down here, if we grab my action and we assign it to the melee attack, and yep, this does work because again, the function signature matches. This one returns void and has no parameters. So rather than having to constantly define your own custom delegate with void no parameters, if you want that, you can just use action. And then there are actually various action definitions. You can add the angled brackets. This means a generic. We're going to cover what are generics in detail in a future lecture. So this you can see there are 16 versions of this type. And these are basically just different amounts of parameters. So you can see there's all the way up to 16 parameters. Basically on these, you can include whatever type you want for the parameters. So let's say an action that takes in an int. What this means is a function that will return voids, and it's going to have an int for the parameter. So the equivalent, for example, up here would be some kind of int like this. So this would equal pretty much this. And down here, of course, since we changed the delegate that we're using, this one is no longer valid. So in this case, we would need to make something that returns void and then takes in an int parameter. Yep, just like this. And if we assign this one to that one, and yep, it does match. So action is really awesome. It's a built-in type, so rather than having to define your delegates, you can just use this directly. The only thing is that action always returns void. So on the various versions that we saw, on the 16 versions, every single one of these is just affect the number of parameters, but they always return void, meaning they cannot return any value. If you do want a delegate that returns something, for that you have the func. And this one works pretty much the same as the action, so this one also has tons of things. So let's put in the generic in order to see all the types. And this one, as you can see, has a generic name tResult. So this is basically going to be the return type, and then has all kinds of those for all kinds of parameters. So this is basically going to return some type and then have any kind of any number of parameters. So for example, in this case, this my func, this one is of type int, meaning it's going to return an int. So let's actually define it. So let's take this one, go down here, and we're going to need to assign it to something. So let's make another function that matches that delegate. So again, this one has no parameters and it's going to return an int. So let's make it return an int and with 0 parameters. And if we take this and let's just return 0. And if we take this and assign it, and yep, it does work. So the built-in action and func delegates, these are super useful. If you have some common use case, you can really just use these two. There's no need to define your own delegates, but defining your own delegate is also still something proper. The one big benefit is, of course, this one has a custom name. So even though this one perfectly matches an action delegate, with the name attack delegate, that makes it a bit more clear as to what the intent is, as opposed to this one func. This one has no clear intent on what it's doing. So they both have their use case, but in many ways, for simplicity, when you just need something basic that works, using func and action, those are excellent. Then for assigning a delegate, so over here we are creating something of some type, then we are creating a separate function and then assigning it. So this works. But we can also do what is called an anonymous function, or sometimes called a lambda expression. So for example, let's define a field of type action. And now when assigning it, we can just put in the parentheses for the parameters, which in this case action has no parameters. And then we do a little arrow symbol, and then let's open and close a code block. So yep, just like this. This is valid code. What we have here is a lambda expression for defining some kind of function that takes in no parameters and returns nothing. So what we have here is pretty much the same shorthand as what we have here. We can place the console write line there, and yep, this is exactly the same as this. Except when doing this, we didn't have to define a completely separate function. So these lambdas, this is another really super useful thing. I use them all the time, especially when writing any code for buttons. In Unity, buttons have a click action, and normally I just use a lambda in order to define what behavior I want when I click on a button, as opposed to having to write a separate function and then assigning it to the delegate. So lambdas are really great time savers, and you can use them on any delegate type. So over here, an action with no parameters, but if we make an action that takes an int parameter, if so, then we just need to define the int parameter over there. And if this does work, and alternatively, if we make a func, let's make a func that takes an int and returns a bool. So this one takes an int parameter, and then over here just needs to return some kind of boolean. Yep, that works. And then alternatively, if you want, you can even simplify this even further. So let's erase all this. Let's put just false, just like this. And yep, this is perfectly valid code. This is doing the exact same that we saw previously. The compiler is smart enough to know that if this delegate expects a return value, it is smart enough in order to add the return into whatever statement we write. So this is perfectly valid code, although normally, like I said, I prefer being explicit. So personally, I prefer to always write everything perfectly. Now, one interesting property about delegates is multicast, meaning how you can store multiple functions inside a delegate. So for example, let's see here our attack action. So we're assigning it to just the melee attack. Let's make another one. Let's make a range attack. And over here, if we do this and then assign it to the range attack, if we do this, and let's just get rid of the other code. So if we run this code, and if there we go, it only runs the range attack. However, instead of assigning, we can do plus equals. And now if we run this, and if there we go, now it ran both. Even though over here on the delegate, we only ran the delegate once, since the delegate itself is storing the reference to two separate functions, it is going to run both those functions whenever we run our delegate. So this means that the delegate itself, it can store multiple objects. It kind of has a list in the background of all of the functions that are stored within it. And since you can do plus equals to add it, you can also do minus equals. So let's run that one, which should run both. then do a minus equals, and then print, and let's see this. And if there you go, so the first time that we ran the delegate, the first time it ran melee attack and range attack, but the second time, since we raised the range attack, we did minus equals, because that the second time it only ran the melee attack. Now, one really common use case for delegates is doing asynchronous programming and handling callbacks. If you're familiar with JavaScript, you're certainly very familiar with this. And in game development, for example, one very common use case is for pathfinding. You tell a unit to move somewhere, and you can pass in a delegate for what to do when the unit gets there. So for example, here's a basic unit class, and it has some kind of pathfinding, so it has some kind of move to function. It takes in a target position, then an action for the onReach target action. So we would create a unit, we would tell it to move somewhere, and we would pass in a delegate. So in this case, it could be a simple lambda, so a simple anonymous function. We could pass that in, then the unit would do all kind of movement, and eventually it would reach the target, and when it reaches the target, then it would call that function. And in doing so, then it would run whatever logic we set when we call the move to function. So if we test this, yep, there it is, now the unit is moving, and after a while it gets there, and yep, it reaches the target. Another common use case is when doing something that contacts a web server, so some kind of web request. I made a tutorial on that, and for that, I made the class receive a delegate for the callback that is called whenever the server responds. So delegates are super useful and extremely versatile. It can be sometimes a little bit tricky to understand at first since they look like variables, but they're actually storing functions. If there's something you didn't understand, definitely go ahead and rewatch this lecture once again and go through the interactive exercises. This is an extremely powerful feature that you absolutely must understand. Now here I mentioned lambdas for making anonymous functions, but there's actually another way of doing something similar. We can create normal local functions. So let's learn the differences between them in the next lecture.